不是啊，是啊，那在我们他们对着4个人都有啊。我已经很习惯用的。
Okay, let's go ahead and get started. So, any questions that came up that people wanted to ask from anything you were doing over the last few days? Yeah, yeah.
For the sort.
For the what?
For the sort.
Uh-huh.
And then we check that it's going with the
Okay.
which mine is K.
Okay.
The power we want to.
And that's not working? Okay.
Is it because there's a blank for the places not in
No, it should still work. The blank should get ordered by whatever the metric is for doing the ordering.
Okay. But it's supposed to work that way.
Yeah.
Okay.
Yeah. So if you're, yeah. So feel free to post a note or to come up and talk to me afterwards. I'm not going to be able to diagnose it on the spot right here. Other questions? So we left off last time talking a bit about some of that if-then-else syntax, and there was that example of a function, and we're looking at some of those variable names that are automatically provided. And so I think that was useful to see some of how this syntax all comes together. And then I just want to close off by talking a little bit about for loops in the shell. And so there are a couple different, there's maybe more things that you can do, but a couple of the things that you can do with looping in the shell is you can basically loop through a set, and that's what we're going to see here in a second, or you can also loop through where you're iterating through, you're just doing iterations and sequentially going through numeric values 1, 2, 3, 4, 5, et cetera, et cetera. So this here is an example of iterating through a set. And it uses this in syntax. So can somebody tell me what they expect this to do?
Just list all the files and add up with the txt.
Okay, so it's going to list out any of the files in whatever the current directory is that end in txt, and then what is this going to do here? So we saw a different kind of syntax for doing this. I forget. I think I may have mentioned that this is another way of doing that. Does anybody remember that? So we saw the backticks as a way of creating a variable, and this is basically another way of creating a variable. Is to say $sign and then put in parentheses. So whatever you want to execute is the stuff that goes in the parentheses, and then the $sign and the parentheses are going to basically create a variable on the fly. And we could assign that as well. We could do something like, say, files equals $sign, and then the stuff that I have in there. In this case, we're basically just sort of making an anonymous variable without a name to it that's then directly going to get iterated over. So this is basically going to create a set, whatever's in whatever file names are the result of doing the ls, and then this is going to sequentially assign the variable file to each of those items that's in that set. And then you can see that all this is going to do is just move the file, and in this case, this is a little bit of additional syntax we haven't seen before, but basically this is syntax that will take that'll take whatever's in file and replace any place that it sees .txt with .r. So this would be a way to automatically take any file name that ends in .txt and make it into a file that ends in .r. So you can sort of see what the usefulness of this might be. You know, somebody shipped you 1,000 different code files that end in .txt, but you'd really like them to end in .r, so the system recognizes them as being R code files and whatnot. Yeah, JR?
I was just wondering, so the backticks and $sign brackets are entirely equivalent?
I think they're pretty equivalent. There's a chance that they might do something slightly different in sort of an unusual case that I'm not aware of, but you can use, and as far as I know, you can use them interchangeably.
Then conventionally, is there one that's preferred?
I don't know. Yeah, I'm not sure if we did some Googling or looked on Stack Overflow, there might be some opinions about that. But I tend to think of them as being interchangeable. Other questions? Okay. Oh, right. I guess I already said that right here. I didn't realize that I'd already put that in. Okay, so then let's now switch over. I'm going to go over to the VM. In the actual, that's weird. I have the VM open somewhere. Here it is. Okay. So in the actual unit2-bash.sh, I have some other examples of for loops here. And so I think maybe what we can do is I'll put one of these up here, let you guys stare at it a little bit and see if you can decipher what's going on here. And this sort of combines a whole bunch of the different kind of functionality that we've been seeing over the last couple days. So take a look and stare at this for a minute or two. Feel free to consult with your neighbor and see if you can figure out what are the various things that are being done here and why it works to do what it's doing. And I'll tell you that the files indicated here are basically just flat text files of meteorological data that have different numeric values for different meteorological quantities. Okay, so let's reconvene. I'm going to turn to my panel here to get some input. So is Nick here? Nick. This is a good way for me to learn names too. So what did you get out of this in terms of what it's trying to do?
Still figuring out.
Okay, well, can you start us off with something?
I think first it's a follow. It starts at this programmable value, which is year.
Okay.
From 1910 up to 1920.
Okay, so it's doing something for every value between 1910 and 1920.
Yeah,
Okay.
and they try to get the file which contains a variable year.
Okay.
Yeah.
So it's looking in this URL, and then when it gets to here, there must be a directory for each of the years, right? Okay. And then what's going on here? So what can you decipher about what the names of the files looks like? So okay, so it looks like there must be a separate subdirectory for each year, and then within that, it looks like there are files that all begin with 3200, but then there's going to be a different month and different year indicating that there's going to be one file for each month of each of the years. Okay, so Kelly, what do you think this is then doing? Once we get one of these files that represents a year and a month, is Kelly here? Yeah. What's going on here?
So it looks for PRCP in each row of that file.
Yep.
And then takes those rows and
Okay, and it looks like I'm making a master file one for every month, right? So I'm making a master file for all the January data, a master file for all the February data. For some reason, I decided I wanted to stratify the data in this way, so I have a file for each month. Okay. And then I'm going through and I'm saying, oh, the result of the wget was to create a local file on my hard drive, but I'm trying to, to glom all these together as one file per month, so I'm just going to go ahead and get rid of that. We're going to go ahead and get rid of that here. Okay, did anybody see what was going on with this IFS business? So when we had the LS one, well, we can just go ahead and do this. If we do ls star txt, well, let's go ahead and assign that to a variable. So files equals, I'll use the backticks in this case. Now if I echo back out the value of the files variable, looks like it is separating them by spaces. So there has to be some convention by which when we use the in syntax, there has to be some convention by which the shell knows what are the separate pieces of that it's doing the iteration over. What separates the items in the set. And by default, that's going to be a space, but we can change that. And in fact, this IFS, if you remember from last time I said environment variables, we talked about environment variables, hopefully, although I don't remember if I said this precisely exactly, they're usually all capitalized. And so this is an environment variable, but we can set it. And in this case, I decided, well, I want to set it to be a colon, and that feels to me a little more clean than using spaces, because spaces get used for lots of things, and it just seemed sort of easier for me to see that this is exactly what was being iterated over if I use the colon instead. So therefore, when it's doing this iteration, it should recognize that this is the thing that's separating individual elements in the set.
Do the same thing to create a comma separated file?
So this wouldn't be, it's not a comma separated file, but you could do the same thing and have a comma separated. Basically, you could have a variable. I mean, the variable is just one variable, but then when it's trying to iterate over it with the in, if you had commas in there, you could change IFS to be a comma, and yeah, do that. And what's your name? Danielle. Okay. Any questions here on anything that was going on here? Yes,
I just have a simple question. How does a master file differ from other types of files?
So, say again, how does master?
Yeah. How is it different from other types of files?
Oh, it's not. It's just on the fly. It's just creating this as a text file. That's the result of doing the grep, and it's just redirecting the output from standard output, which would usually go to your screen, into the file. And if it doesn't yet exist, it will create it. But if it does exist, it'll just append onto the end. So you notice I didn't need to do any pre-processing where I set up that file to exist to begin with. It just got created. Would have just gotten created on the fly. Yeah.
When you say
Julie.
that IFS, is it just limited to the months January, February, March, or April, or that's just setting the time?
No, in this case, this is me saying for some reason I've decided only to download the files for those first 4 months of the year, not the 12. In this case, probably just because I got tired of typing.
If you wanted them all, you'd have to type them all. There's not a shortcut.
Yeah, I mean, there may be some automated way to do that we could come up with, but in this case, yeah, I would probably just type them. So we could actually run this. Let's see if this would actually work. W. I'm going to make a little working directory and cd to that so that we do all this downloading in that directory. Okay, so it looks like it's, this might take a little while. So it looks like it's sort of cycling through. It's downloading files with wget. This is the sort of thing that you would see. I'm not sure whether we want to wait for this to all happen because it's going to do 4 times 11, 44 different files, and these look like they're taking a little while. So let me just hit Control-C here. We can see what happened so far. It looks like it was indeed creating those 4 different master files. And if we just take a peek into some of them, let's say lesson, so indeed it does look like it's pulling up those rows. And you might have guessed that what this indicates is this is a precipitation record, so a rainfall or snowfall value. I believe in these files that there are also rows for things like temperature and other things, and in this case I just wanted to get the precipitation. This is an example. This is sort of segues into what I was going to start talking about in terms of Unit 3. this is an example of what's called a fixed width format. So you'll notice we've been working with files that were, say, separated by commas, or maybe where the fields were separated by commas, or some other kind of convention like that. And this is something where there's a fixed number of characters that are assigned to each of the fields. And because I've worked with these data, I happen to know that the first three are a sort of an identifier, I guess, that this is a daily value. And then there's a station ID here in the next 10 or 11 characters. And then this indicates what kind of record it is. In this case, the precipitation one. I forget what the HI means. And then this is 1910, I think, for the year I think this is the year 1910. And then maybe, I think this is the first month. And then there's a whole bunch of other stuff. And this, I think this is actually different data for each of the days in the month, happens to be how this is set up. So it's maybe in some ways sort of an inconvenient format, because you might want to have it where each day is a separate row of data or something like that. So you might need to do a bunch of pre-processing to deal with these kinds of data. Okay, any questions before I turn to the next unit? Yeah, Andre?
For that data that you just output, were those zeros, I think it was like 5 zeros in a row, were those just like separating out the actual data, or is it actually zeros and that's the data? Sorry, it's probably not important, but
That's okay. Yeah, I think what's going on here is, I think these are the actual values, and then I think this is like a code for the, so I think this is a code for the first day, and this is the data for the first day, and a code for the second day, and then the data for the second day, and so on and so forth, in these sort of repeating pairs. And I think these codes, I think the 1 here and the 2 here and the 3 here indicate the day, but I think there's other codes embedded in here, like, was there something wrong with this measurement, or something unusual, or the measurement was missing, or also those, so you'd have to go into the metadata to sort of really figure out what was going on. And actually, for those of you who were here last time when I gave you the example of doing that grep on thousands of files at once, and I was grepping for an S, I was actually indeed looking for an S in files that looked like this, because an S indicated some weird measurement problem, and I wanted to see if that happened any of the time. Okay, any other questions? Yes, and remind me of your name.
Mike.
Mike.
If you wanted to look at this and take it into R or something, would you just add an extension, or what would you?
That actually is going to get right into what we're about to talk about next, so yeah. Any other questions? Okay, so let's switch over to Unit 3. There's a whole bunch more stuff in Unit, at the end of Unit 2 on version control, and that's the stuff that Jared will be talking about. I forget if he's asked you to look through that in advance or not, but he may have been communicating with you guys about that. And so he'll be going over a lot of that material in section today, and maybe in possibly either next week or in a later week in section, some of the more advanced Git stuff as well. Okay, so let's switch over to, I'm going to switch over to RStudio here on the VM, and I'm opening up unit 3-rinput.r. So for the most part, actually in subsequent class sessions, I'll probably mostly be in RStudio, because now we're going to switch over to doing a lot of stuff in R. And I'll probably do it in the VM, although I might just do it in the RStudio that's here on my machine. And I'm going to switch over to the PDF for the third unit here. Okay, so the basic idea of this unit, it's not too long, we'll go through hopefully most of it today, is to talk about basically different kinds of data formats that you might encounter and how you might deal with them in R. A lot of the ideas of how you would deal with them would carry over if you were dealing with them in Python or some other language, but sort of in keeping with the rest of the course, we're going to be mostly focused on doing stuff in R just because we need to sort of choose one thing to, one context to be working in. Okay, one important thing to remember when you read data into R is it's all going to be read into memory. So if you're trying to read in 100 gigabytes of data, you're going to run into problems if your machine has less than 100 gigabytes of RAM. So that's one thing to keep in mind. It means that R is going to be able to process through the data often fairly quickly once it's sitting in memory, but you can very, very easily overwhelm the amount of memory that you have on the machine. And that's particularly true for the VM, which by default only has a limited amount of RAM. Okay, so we've already sort of talked about just flat text files, often that might be delimited in some way, where maybe each row is an observation, each of these different delimited columns is a different variable or field. These might be delimited by a particular delimiter, or as I just mentioned with that precipitation file, it might be a fixed number of characters per field, and knowing which of those it is going to be important for then being able to read in the data. Let's see. Not too much more to say there. One thing to mention you'll sometimes see is that it turns out that in Unix, the character, so ASCII, we'll talk about this a little bit later on or on Wednesday. ASCII is basically a set of 128 different kinds of characters or control. What's the word I'm looking for? Control thingies. I'll come up with a better word for that. Like tabs and new lines and things like that. And basically the ASCII character that's used to indicate that there's a new line in Unix is a /n. And the problem is, let's see. Oh, right, okay. So in Unix, there will only be a /n at the end of each line, and in Windows, there will be a /n and a /r. And so the result is that if you take a text file that's created in Unix and bring it into Windows, sometimes Windows won't realize that there's a line break because it only sees the /n, and it doesn't see the /n and the /r. So you sometimes will see a Unix text file in Windows looking like it's all just one humongously long line. And equivalently in Unix, if you open up a text file in an editor, sometimes you'll see a little $m at the end of each line, and that $m is some representation of this, what Unix thinks of as this extraneous /r that's in the Windows file. So sometimes you may need to do a little bit of conversion to go from a text file that was created in Unix if you're bringing it to Windows, or vice versa. So there's a little bit more information about that here. I'm not going to go into the details of it, but just sort of so you're aware of that. If it comes up for you, you'll need to go look into that. There are obviously sort of tons and tons of different formats for different kinds of data structures. I'm just listing a few here. Some of you, if you work with sort of gridded data, particularly sort of environmental or geo kind of data, you often will encounter something called netcdf or HDF5, and that's basically if you've got like a latitude, longitude grid and also a grid in time. These are formats that are often used for storing those sorts of data. And in general, for all of these different kinds of formats, if they're fairly popular or common formats, R is going to have some package that will allow you to read data in from those formats really readily. So you don't want to go try and write up your own code to read in these formats. Your first step would be to go and look around and see if there's any stuff already provided. We can also read XML or HTML files directly into R, and the XML package is pretty useful for that. We'll see an example of that. And then just to mention that if you've got data files coming from a format that's for particular other kinds of software, like in particular other statistical packages like Stata and SAS and SPSS and stuff like that, you can often read in directly from those formats. And those functions for doing that are in the foreign package. So let me actually open it up and see. Are there other formats that people tend to work with in their work as you go about your daily lives in whatever discipline you're in, if you're not in stats? Other common formats, or if I covered, does it seem like I've covered a lot of the useful ones? No? Okay. Well, maybe I did a good job, or maybe it's just there's not as much. Maybe there are others out there, but we don't have a good representation of you guys here in terms of what those are. There are ways to read Excel files into R if you need to do that, but more commonly what I would suggest doing is just going into Excel, exporting the file out exporting the table, the spreadsheet page out as a CSV file, and then reading it in as a CSV. And in general, you could read what I say here. In general, storing data in Excel is really not a great idea, particularly if you're going to be sending it to somebody else, because it's not really a data storage format. So it's much better to convert it into one of these other kinds of formats, like the ones I just mentioned, and then use that as your storage format. Okay. Any questions or comments? All right, well, let me switch over. I'm going to go through a little example of reading data into R using read.table. This is actually an example I did in the boot camp, so some of you will have already seen this. And so read.table is sort of your read.table and read.fwf are sort of your workhorses for reading data in. Read.table will read in delimited files, flat text files, where you can think of operating them as rows as sort of observations and then potentially in multiple fields. And read.fwf is if you've got a fixed number of characters for each of the columns. So I could have used read.fwf, for example, to read in those the result of doing that grepping and the precipitation data that we just saw. Okay, so let's see an example in terms of read.table. A couple of the things that one needs to watch out for here is that read.table is going to try and read in things as numeric, read in columns as being numeric into fields of a data frame. But if it finds anything that it doesn't interpret, it doesn't recognize as being numeric or as a missing value, it almost always makes it into a factor variable, which it can be pretty inconvenient. Both because you might not think of it even as a character string kind of value, and because oftentimes you might end up having unique values for every single observation, in which case it's sort of silly to have it as a factor, as a categorical variable. All right, so let's just go through. Whoops, I didn't want to do that. I'm going to use RStudio in the VM. For some reason, this is not taking me to VirtualBox. I don't know why that is. Oh, I see, because the VM is a separate tab. Okay. Okay, so here's we're going to read in this file. This is a file that was taken from the Kaggle.com sort of machine learning prediction statistics website. And it's just a subset of a bunch of data from an Australian freeway of basically information about how fast traffic was flowing on different segments of a freeway. So first, as usual, we need to make sure that we're looking in the right place in the on the file system. And I'm going to set the working directory to be pointing to the repository. That's weird. Oh, it's just directly in the root directory. Or in the home directory, I mean. Okay, so let's set it to be sort of the units directory, and then that'll fit with the fact that now I'm setting the working directory to be going to the data subdirectory. So if I go ahead and read this in, I can then say, okay, I can then ask the question of how have the different columns been read in? And I'm going to do this with an sapply. So by now you guys have been playing around with R, or you already know about this, that a data frame can be treated as a list. So I'm going to do an sapply where I ask what's the class of each of the variables in the data frame. And indeed, when I do that, what it shows me is that each of them has been treated as a factor. But if I go and I look at that file, so I'm going to go to the data directory, I'm going to look at this RTA subfile. When I look at it, to me it looks like, you know, from just starting to scan through it, it looks like all of these things are numbers. So this is a very common occurrence. You do this, you're like, oh, this file looks fine, I'll just read it into R. And read.table should be able to handle it. And then you read it in and you realize, oh my, something went wrong. The only thing that's obvious here that's not standard numeric values is some sort of date time information that's there. So we could ask something like, well, let's just take the second field that we've just read in and ask what are the levels of that quote-unquote categorical variable and see what it says. And if you do that, it says, oh, well, it looks like there are a number of them that are being treated as sort of character or factor kind of values, but then you'll notice there's an X down here. So this is the sort of thing that will tend to happen, is there'll be sort of an extraneous character in there that you didn't realize from just sort of looking at the file by just sort of paging through it, or maybe you were lazy like I was initially here and didn't actually look at the file at all. I just, I sort of looked at a few rows and just then tried to read it in. So presumably there might be extraneous non-numbers in there because there are data entry errors. So that very commonly will occur. Somebody mistyped something and there's a 123C57 or whatever happened when they were typing things in. Or in this case, what's going on is there's a missing value flag that presumably is hopefully indicated in whatever metadata come with this data file, but that we didn't realize until we did this. So a couple arguments that are useful for read.table are to tell it what string should I recognize as being missing values. So I'm going to specify that to be the sort of standard R and A string as being missing value, but also that these X's are treated as missing values. And then something that I use a lot is to say, don't make anything that you see as a string, don't automatically convert it to any field that you see looking like it's character or strings. Don't convert it into factors. Just keep it as a character vector. So that's a fairly handy one to use. And so now if we do this, we can say, okay, now if we do the unique on the different values, we can see indeed it looks like it did read in everything as numbers. There are no quotes around the numbers when R prints out the result. And it looks like the only non-numbers in there are missing values, which is as we would hope it would be. And I could just do a little bit of checking to say, the second time I did the reading, I read into something called DAT2 instead of DAT. So I'm going to go back to the original DAT that I read in, which still has all the factor and character stuff going on. And if I ask I just want to ask which of the rows correspond to any blank spaces, because I want to make sure those blank spaces got converted to missing values. And so now if I do that, and so this identifies rows, and now I'm going to use those rows to see what those rows look like in the DAT in DAT2. So if I do that, what I see is that indeed, here's an example of a row where in DAT it had a blank space, and you can see that in DAT2 it looks like it has missing values substituted in here correctly. So it looks like I was just sort of doing some checking to make sure that looked reasonable. Okay, so I don't want to say too much more about that. Many of you have probably encountered this sort of iterative process of trying to read a data file either into R or some other language, realizing there's something weird that you hadn't recognized was going on, and having to go back and adjust some options as you read it in. Any questions? And actually, does anybody have any good examples of this sort of thing happening to them where they've had to sort of work around something like this? No? Quiet today? Okay. So another thing you can do is basically force R to recognize certain fields as being of a particular type. And so you can actually tell it what the class of each of the different columns is. And so in this case, this is some data on the DNA sequences from the HIV genome in a number of different patients who are infected with HIV. And so by looking at the data, I recognize, I want to read in the first field as an integer, then an integer, then a character, then a character, then a numeric, and then an integer. So this is another way of sort of forcing things to get read in the way that you want them to get read in. And the other thing that's useful about this is if you tell R exactly what the different types are of each of the fields, that will often speed up how quickly the data gets read in. Because instead of R having to basically, I'm not sure exactly how it does this, but instead of basically having to sort of pass through the data and try and figure out what each column is, and that probably involves maybe multiple passes through the data in some way or some sort of checking and whatnot. Here it can just basically just read it right in because it's already just slotting everything into the fields, into the types of fields that you've told it to look at to do. So if we look at what this HIV sequence data looks like, we can see that in this case we've got some field names, and then it looks like it's comma separated, and then we've actually got the whole DNA sequence here, at least as that third variable. And so this is another way of me saying, don't turn all those DNA sequences into factors. There's probably going to be a unique one for every patient, but make sure just convert those directly into character strings. And then recognizing that in this case I'm going to treat this one as a real valued field, and these other ones as integer valued fields. Okay, so if I go ahead and do that, I could then look at, for example, the top of sequence and see what it looks like. And it looks like things have been, it's a little bit hard to see because there's so many, these things are so long. So let's just look at the first one. Okay, so it looks like it got read in a reasonable fashion. I might be a little concerned that there aren't quotes around the DNA sequences, and so I might be wondering if they got read in correctly. So if we go back here, so it's interesting. It looks like, okay, so here we've got, oh, okay, I was worried about this one, but I think that's just identifying this as the first row, so I think that's fine. But I would be worried if there were not seeing any quotes around the third one that's supposed to be a character. I might be worried that that's not being treated as a character, but it looks like it actually is. So indeed, it looks like it read things in the way that I did request, and it's usually good to check these things. Okay, another thing. Any questions about that? Okay, another thing that you can do is you can basically just read in a whole line at a time and then do your own parsing of the line and your own processing of the line. And so that's actually what read lines will do. So suppose I had that, I think this precip.txt is actually in a similar form to those files that we were just looking at. In fact, it might have been created from them. Yeah, so that looks like that same format. So this is that fixed width format. So I could read that in with read.fwf and do the processing sort of on the fly with that. Or maybe I just want to read it in line by line and then do my own processing of each of the rows. So this is an example of doing that. I'm going to use this read lines function. And then if I look at the length of dat, that is basically a character vector that has 7,600 different values. So the first one, I could look at the first one, and indeed it just got read in as a character string, and I'm now going to have to process it myself from this raw sequence of character elements. So I could do things like this. We haven't actually seen the substring yet, but you would have seen it in the boot camp or in looking at some of the, potentially in looking at some of the problems that Jared gave out. So here I'm going to take all of the values in the 4th through the 11th characters in this and each of the elements of dat. I'm going to extract those out and I'm going to convert them into a factor variable. And I can do that sort of processing for all of these. And so if I look at that, that works somewhat, but in this case I would recognize that I need to then go another step and convert these from character strings to numeric values. So that's what this is here, then wrapping that in, wrapping an as.dat integer around that. Okay, so there's not too much to that. That's all fairly standard. One other thing I wanted to mention here is R has the ability to read in not just from a file, but these things called connections, and that would basically allow you to do a whole bunch of different things that I've sort of indicated here. You could, for example, read in from having done a Unix operation in the shell, and so that's what this pipe will do. So this is basically saying, do this in the shell, and then pipe that basically into R, into the read lines, into basically one of these connections, and then read lines is then going to go and process that. So if we did this, we can look and see what dat looks like after doing that. And now if we look at dat, indeed what it is it's just a sequence, it's just a set of character strings that are really just the result of having run ls minus al, and just one line for everything that got output in the, as if I had done that here in the shell. Okay, so we could also unzip things on the fly. So this gz file, if you had a gzip file, this would unzip it on the fly, and that would create. It probably won't create dat.csv on your hard drive. It'll probably just basically just be working in memory and create in memory and then pass it right into read.csv. And you could also read in from just directly from a file on the web as well. With, in this case, read lines might be a nice way to do that. If you're just reading in HTML, you might read in the entire HTML file just line by line, and then process through it to parse it and work with it. Although in this case, what we'll see is that there, if you look into that XML package, there are probably other ones, other R packages that you could use. They're probably going to save you a lot of that time of writing code to do the processing of the HTML. Okay, any questions or comments? All right, there's a little bit of an example here of processing file. It's in blocks. So if you had a really big file you're trying to read into R, and I mentioned R is just going to use memory, is if it's going to try and store that the entire result of reading the data into R, it's going to be storing that in memory. So maybe you've got 10 gigabytes or 30 gigabytes of data, and you don't have enough RAM to actually have a data frame that's that big for storing the data in R. You might want to read through chunks of the file, process them into some smaller representation, and then continue on your way and basically iterate through chunks of the file. And this is an example of using one of these connections, where I basically say, open up this file for reading, and I'm not actually going to read it in yet. I'm just establishing this connection, this relationship between R and the file, and then I'm going to go ahead and read from that read lines from that file via the connection in blocks of a particular size. So this would be a way that you could read in blocks of a file at a time, and you'd presumably within the iterations here do some processing that would then compress down the input that you got, and then sequentially work your way through the file. And then just a final example here. It turns out I'll mention this as well. You can also, once you have a character string in R, you could actually then create this thing called a text connection, and basically you use read.fwf on the text connection to basically treat the text string that's already in R as if it's a file that you're reading in that has a fixed width format. So there are a lot of nice tricks and handy things you can do here. And then I'll just do a last example. I thought this was kind of fun. So you can read in tables of HTML. So I'm going to read in any tables in Brad Pitt's Wikipedia page. And it turns out the second HTML table in the Wikipedia page is basically all his film credits and what his role was in each of the films. So if we then go ahead and look at that, so this should be a data frame that it got read into, and you can sort of see what. Oops, make this a little bit bigger. So you can say, okay, it started in 1987, he was in a movie called Hunk, and then in a movie called No Way Out, and then it's kind of cool. It says what his role was, and you can see, like, well, he wasn't Brad Pitt in 1987, so he was just a guy at the beach with a drink, and then he was an airport cop, still with no name, and then he was a waiter, and then he was a guy at a fight. But then eventually, he started to get roles where he actually had a name, and he was Rick, and then Brian, and then he graduated to actually having a last name. And then he was Brad Pitt, I guess. But if we were to look at the HTML file for this particular page, it's got a whole bunch of these pages. So let's see. I'll just do this outside the VM. That seems easier. All right, so it's got all this text here, and then it's got some contents, and then all this stuff, and then somewhere down here, I think, it must have tables somewhere in here. Huh. Maybe I'm looking at a different HTML file. It was like filmography or something like that. Yeah, so it was this page. So it's got some text, but then it's got all these tables in here. For some of the different things that he's done. So you can imagine we could write code, and we're going to do some of this sort of thing in a few days when we get to regular expressions, where we basically read in a text file that has a whole bunch of stuff in sort of crazy formatting, and then we actually process through it and use various text processing and string processing tools. But if we can take something that's already more structured, where there are packages developed to read this in and not have to do all of that ourselves, that's going to be a lot easier. So we could have produced that data frame just by reading this HTML in as text and then processing it ourselves. But obviously this is quite a bit easier. Okay, so there's a whole bunch of stuff in here in section 3 about how do you format output from R. It's fairly dry but quite useful, and I'm going to leave that to you guys to look at on your own. And there's just a whole bunch of stuff in here it's useful to know, and to know sort of what some of the options are, so that you have it in your head when you actually need to go and format output nicely, to know that this stuff exists, but we probably don't need to go through it in detail. So the last thing I'll talk about a little bit, and then I'll just finish this off on Wednesday, is this idea of encodings. And so I'm by no means an expert in character encodings. So this is just sort of a little bit of stuff that I've picked up along the way to sort of get me past a few rough spots in terms of dealing with files where there are characters coming in that are not sort of standard English alphabet characters. And so I'll just give you a sense of a few of the tools that you could use to deal with this. So basically, if a file is an ASCII file, it basically only can represent 128 different characters and control codes. I said control thingies before. Codes was the word I was looking for. And that's basically because ASCII is an encoding, a numeric encoding of the different letters of the alphabet and these control codes and other like commas and semicolons and stuff like that. But any given ASCII character is stored basically as 7 bits, 7 zeros and 1s. And what that means is that you can only represent 128 different characters in the ASCII encoding. So the result is ASCII can't handle, for example, European languages where there are accents on the letters. It certainly can't handle Chinese characters or any of the other kinds of characters that would come up when you're working in languages that are not just very simple, plain English. So sometimes what you'll need to do is sometimes you'll get a file that is represented, that contains these other kinds of characters in it, and you'll need to let either R in our case, the language R in our case, know what the encoding of the file is, or if you're working in some other language, you may need to let that other language sort of know what kinds of characters are represented in this text file that I'm passing you. This is something more complicated than just having ASCII characters in it. So there are lots of these different encodings, which are basically mappings between the different characters that we want the computer to represent, and basically numeric codes, a unique code for each of the different characters. So ASCII is this mapping between the 128 characters and this 7-bit representation of those. One that's really common and is actually used in R by default is something called UTF-8, and that basically allows you to represent up something like 110,000 different characters. And so that is quite flexible. I would imagine this includes, so roughly speaking, how many Chinese characters are there? Is that a hard question to answer? Tens of thousands? Is that roughly right, or more than that? Huh? 10,000? More than that? Okay, so I don't know. I would guess that if this is UTF-8, it's this Unicode, it's supposed to be universal. I would guess that there are the characters for a bunch of the important Asian languages in here, although I didn't actually check that. And then there's another one that will sometimes come up, and that's the example that I'll show you, I guess, next time, which is this Latin 1 encoding, which includes the various different characters that allow you to write out most of the European languages with all the different kinds of accents on them. And so sometimes what you'll need to do is basically tell R that the text that it is working with is in, say, Latin 1. By default, it will think that it's in this UTF-8. And so sometimes you need to tell it, hey, it's in some other encoding. Either tell it to recognize that it's using another encoding, or convert from that other encoding into UTF-8. So as an example of this, this is a concrete example that came up when we were processing some internet log data in class either last year or 2 years ago, and the students started reading them in. There were a bunch of errors that came about, and the reason was that there were things in the file that looked like this, and this is basically a hexadecimal. This /x stands for hexadecimal for base 16, and I think the next two characters after this are basically in the Latin 1 encoding, and they're basically encoding things like A with an accent and things like that. And so R wasn't able to recognize what this was unless you tell it, hey, this is coming in this Latin 1 format, and recognize that if you see things like this, that's what the encoding is. So when we pick this up next time, we'll spend a few minutes just going through this example and seeing that kind of conversion. And then we'll start in on Unit 4 next time.
Yeah, sure.